Hello everyone. The title of this video is Simplify Rational Expressions. And in this video I'm going to be going over many examples in which we're given a rational expression or a fraction and asked to simplify that fraction. Now, to simplify a fraction, a fraction is considered simplified if the numerator and denominator have no common factors. All right. So I'll write out the steps of what I'm doing when I get into the first example. Now, all the examples I'm going to be doing in this video are taken from a free online textbook at openstax.org. And this textbook is Intermediate Algebra, 2nd edition. I am in section 7.1 on multiply and divide rational expressions. And the exercises I will be doing is under the heading Simplify Rational Expressions. Exercises 5 through 28. Alright, so that's 24 examples in this video. Now, if you'd like to skip around, if there is a specific one of these exercises you'd like to see, just start counting. This exercise 5 will be example 1. Exercise 6 will be example 2. All the way down to example 24 will be exercise 28. So for instance, if you wanted to see exercise 25 here worked out, that would be example 21, right? You take it, again, exercise 5 is number 1, then you add 20 to get to 25. This would be example 21 in the video. So I'm going to have timestamps for each example in the description of the video, so you can bounce around and navigate through the video if you wanted to see a specific one. Okay, so example 1, and all these examples, and I'm going to do like 4 examples per page. Right? We're asked to again simplify each rational expression. And the first couple examples, we're given fractions, rational expressions with no variables, right? No letters. So number 1, we have negative 44/55. All right, so I'm going to write out on this separate sheet of paper here what I'm going to be doing when simplifying a rational expression or simplifying a fraction. Alright, so the first step is I'm going to be factoring the numerator and the denominator completely. Alright, a rational expression by definition has a polynomial in the numerator and a polynomial in the denominator. So when I say factoring, we're talking about factoring polynomials. Right, so I'm going to factor the numerator and denominator completely. All right, second step. Now I'm going to be assuming, alright, this isn't a video about factoring. I've put out previous videos about factoring, or you can look up your own or read the text. That text at openstax.org, the Intermediate Algebra 2nd edition. All of chapter 6 in that book is about factoring polynomials. So in this video I'm going to be assuming that you know how to factor polynomials, right? You know all these methods. Factoring difference of squares, sum of cubes, difference of cubes, factoring by grouping, the AC method for factoring quadratic trinomials, and so on. Right? I'm assuming all that knowledge of you. So if you need to brush up on factoring, go back and please do that. Alright, so factoring the numerator and denominator completely, then I cancel, and I put cancel in quotes because technically they're not going away, they're just becoming one. Cancel any common factors that the numerator and denominator might have. Right, because if a factor goes into both the numerator and denominator, then you cancel them. They just divide to be one. Really, they just become the number one. And that's it. And a little side note. I'm also going to be stating the values that the variables cannot take. Right, I will also state the values of the variables that will make the expression undefined. All right, get in the habit of that. The reason for this is you can't just plug in anything for the variable. Sometimes sometimes there will be numbers that when you plug them in to an expression, you'll be dividing by 0. And just remember, right, I'll write this note one more time, right? You can't divide by 0. Right? Keep that in mind. A denominator, right? A fraction is really division. This is like 44 divided by 55, right? You can't divide by 0. Right? A denominator cannot be 0. Okay? Alright. So in this first example, negative 44 55ths. Now it's going to be a negative number all the time. Alright, this negative sign's not going to go away. So now I'm going to factor the numerator and denominator completely. Now 44, if you want to do like a factor tree, right, you might have seen factor trees before. Here's 44. And I obviously that's 4. 4 goes into this 11 times, right? And you factor it completely, right? You break it down until there are prime factors. 4 is not prime, right? 4 can be broken down to 2 times 2. And then here are your prime factors. So the numerator, now you can write 44 is 2 squared times 11, right? That's nothing wrong with that. But just for the first several examples in this video, I'm going to write each numerator and denominator as a product of each factor individually. So 44 is 2 times 2 times 11. Right? Writing out all the prime factors of the numerator. And then for the denominator, right, 55 is simply 5 times 11. Right? So that was step 1. Right? I factor the numerator and denominator completely. And then here comes the cancellation, right, of any common factors, or dividing common factors to be the number 1. Right? Anything divided by itself is 1. So I look at the factors of the numerator, right, 2, 2, 11. Look at the factors of the denominator, 5 and 11, and they both have this common factor of 11. Right, common factor. And 11 divided by 11 is 1, so that's what I mean by canceling, right? These just become the number 1, technically. All right, but you don't have to write the number 1. I'm not going to do that for the rest of the examples. And then you write what's left over. So this is negative, and the numerator has factors 2 times 2. Right? Well, 2 times 2 is 4. Denominator is simply 5. Right? And there we go. Right? the final result, the simplified fraction, negative 44/55, reduces, simplifies to negative 4/5. Right? Alright, so same thing for example 2. Now it's, the two polynomials here in the numerator and denominator are just constants, 56 and 63. Right, again, if you want to, when we go about factoring things completely, 56, well, that's clearly a multiple of 2, right, because it's ending in 6 there, and that'd be 2 times 28, and 28's not prime, and that's 2 times 14, right, 14's not prime, that's 2 times 7. And here are the prime factors. It's 2 to the third power. You could write it this way if you wished, times 7. But like I said, these first several examples, I'm going to list off every factor individually. So 56 is 2 times 2 times 2, right, 8 times 7. And 63, now 63 is 9 times 7, and 9 is 3 times 3, so this is 3 times 3 times 7 when you factor it completely. Alright, then I do the cancellation of common factors. Well, the only common factor I'm seeing is the 7's, right? So I'll cross those off, I'll get rid of those become 1, and then I can simplify, right? All I'm left with in the numerator is 2 times 2 times 2, which is 8. Denominator is 3 times 3, which is 9. And there we go. Right, the 56 divided by 63, or 56/63, is the same value as 8 divided by 9, or 8/9. Right. And I guess if you'd like to, you can always, if you don't believe that they're the same, maybe bring up a calculator and say, hey, take 56 divided by 63 is 0.8 repeating, right? 0.88888. Take 8 divided by 9, and look, it's the exact same value. I know this is kind of tiny on your screen, but that's one way you could check with just numbers anyway. Obviously, with variables, it'll be a little trickier to test with a calculator, but these are the same value, 56/63 and 8/9. Okay. Alright, so now we get into an example, example 3, and for really the rest of the examples in the video, we have rational expressions with variables. So I have 8 times m cubed times n in the numerator, divided by 12 times m times n squared in the denominator. So remember I mentioned off to the side, I'm going to list the values of the variables that you can't use. What makes the denominator 0? So off to the side here, I'm just going to put down that m can't be 0, right? Because if m were 0, you'd have 12 times 0 times n squared. You'd have 0 in the denominator. Also, n can't be 0, right? Because again, if n were 0, the denominator would be 0. Right? And do this before simplifying. Right? Do before canceling common factors. Right? Do before canceling. Right? 1L, 2L's, whatever. Okay. Alright, so just keeping this in mind, now I'll go through and do the simplification. So remember, I'm factoring the numerator completely. I've got 8, which is 2 times 2 times 2. M cubed means m times m, right? And this is, again, it's all multiplication. Because they're all touching. There's no plus or minus signs here. And then times m, times n. So here are all the factors of the numerator. Same thing for the denominator. 12 is 2 times 3, right? 4 times 3 is 12. Times m, right? M to the first, times n squared. So times n, that's n squared. And now comes the, canceling of common factors. So I'm seeing there's a common factor of, there's a 2 here, 2 there. They still have a common factor of 2. Now there's no more 2's in common. There aren't 3's in common. There are m in common, right? M there, m there. No more m's. And then n. Right? There's an n there and an n there. Right, so lots of crosses there, lots of cancellations. And then finally, what this is equal to, the numerator, I'm left with the factors of 2, m, m. 2 times m times m, that'd be 2 times m squared. Right? M times m is m squared. Denominator, I have 3 times n. So 3n. And there you go. I'll box that in. Alright, so that means the value, so the value of this fraction is the same as the value of the first fraction. Right, as long as you don't replace m with 0 or n with 0. Alright, and you could test this out. Right, you could test this out with any value of m and n you wish, as long as m's not 0 or n's not 0. So for example, right, say if m were 1 and n were 2, you'd have 8 times 1 cubed times 2 divided by, and then 12 times 1 times 2 squared. This would just be 16 in the numerator, and then 48 in the denominator. Right? That's in the left side, the original fraction. Then you go to the simplified one. We have 2 times m squared, right? So 2 times 1 squared divided by 3 times n, 3 times 2. And you're seeing I'm getting 2 in the numerator, 6 in the denominator, and both of these are the same value. They're both 1/3, aren't they? They are the same. And go ahead and do it with other values, when m is 5, and if n were -2, whatever. These should have the same value. You could just do this all, I'm not going to do this, but you could do this all day long. Replace m and n with anything you want except 0. Right? Because again, if I replace m with 0 or n with 0, the denominator of this fraction will be 0. You'd be dividing by 0 and you'd have an undefined expression. All right. Okay, great. So again, hopefully that makes sense. When you're done simplifying, if they truly are the same expression, they should take on the same value no matter what you plug in for the variables, as long as you don't plug in something that'll make any denominator 0. Right? Alright, so same kind of example, example 4. We have 36 times v cubed times w squared in the numerator, divided by 27 times v times w to the third. So again, one thing I'm noticing is that v can't be 0, w can't be 0, right? Because if I were to let v be 0, this denominator would be 0. If I were to let w be 0, the denominator would also be 0. Right? So just keep that in mind. You could replace v and w with anything you like, except 0 for right now. Okay, and then factoring the numerator completely. Now 36, that's 4 times 9, which is 2 times 2 for the 4, times 3 for the 9, right? That's 36. V cubed, right? That's times v times v times v times w squared, right? Times w times w. Now, after a certain point, I'm going to stop doing this, right? I said I'm only going to do this writing out every factor for the first several examples. If you see how many are going to cancel right away, you can do that. You don't have to write out every individual factor like I'm doing here. Like if you notice, hey, there's v to the third as a factor in the numerator and v to the first as a factor in the denominator, that means you should know that one of the v's will cancel, leaving you with v squared in the numerator, right? So like you don't have to write out every individual factor if you don't want to, if you see something faster. I'll eventually get faster. 27 is 3 times 3 times 3, right? That's 27. And we have times v to the first times w cubed, right? W. And now I'm canceling common factors, right? Well, there are no 2's in the denominator. There's a 3 here, a 3 there. A 3 in the numerator, a 3 in the denominator. A factor of v in the numerator, a factor of v in the denominator. 2 factors of w in the numerator, 2 factors of w in the denominator. All right, so I've canceled all the common factors. And now what's left over? In the numerator, I have 2 times 2, which is 4, times, and then v times v should be v squared. And in the denominator, I have 3 as the numerical factor left over times w. Right, and there we go. That is as simple as that fraction will get. 4v squared divided by 3w. And once again, if you want to test it out, replace v and w with any numbers except 0. And the original fraction's value should be the exact same as the simplified fraction's value. All right, an easy one would be to replace v and w with 1. If I replace v with 1 and w with 1, you'll have 36/27 is equal to 4/3, which is true. Right? But again, it doesn't have to be for, v is 1 and w is 1. V could be 20 and w could be 3/5. You could replace v and w with any numbers you wanted except 0. And these two fractions, these two expressions should have the same value. Alright, so now, so far, every single polynomial we've seen in the numerators and denominators here have had a single term. Right, one term, one product. There hasn't been addition or subtraction. So now we're going to get into polynomials with multiple terms. Again, I'm assuming that you know how to factor. Right, so be careful. Be careful. Remember that when you're canceling, this is a very common mistake. I'll say you may only cancel. You may only cancel, cross out common factors in the numerator and denominator, not parts of terms. This means that you have to write the numerator and denominator as a product, and then you can cancel, not as a sum or a difference. Right? So again, you must first write numerator and denominator as a product, as a multiplication. before you can start canceling. Because very often, all right, here's a common mistake. All right, so you see number 5 there. All right, you have 8n minus 96 divided by 3n minus 36. Too often, I see people do this. Oh, there's n there and n there, so I cancel them. Leaving me with 8 minus 96 would be negative 88. And then 3 minus 36 is negative 33, and then this is positive 8/3. You know, because 11 goes into both of those evenly. Why is this wrong? Well, what you're saying here is that this fraction is always going to be 8/3. Well, if you let just let n be 0 here, this numerator would be negative 96. This denominator would be negative 36. Let's see, this is 8 times 12. That's 3 times 12. All right, this ends up being 8/3. So that's a bad example. If n were equal to 1, all right, you know what? I'll make it easier. Make it 10. How about if n were 10 though? All right. How about if n were 10? You'd have 80 minus 96, which would be negative 16 in the numerator. You'd have 30 minus 36 would be negative 6 in the denominator. 8 times 2, 3 times 2. You know what? This is a bad example. I am very sorry. I'm just now seeing it. When we do this the proper way, it'll end up being 8/3. This is lucky. This is a very, very lucky example. I am so sorry. This actually ends up being correct, 8/3. Yeah, but I'll show you again number 6. Like you can't just cancel the p's. Same thing here. You can't just cancel the n's. All right. Yikes. All right. So that was a bad. I'm sorry about that. This ended up being correct somehow with the bad canceling. Right. This is bad canceling. You don't just cancel terms. You must first write the numerator and denominator as a product. I'll show you again in example 6. All right. Looking at example 6. Yeah, example 6 looks like it won't work, and I'll show you. All right. So anyway, let's get back to example 5. First, we factor the numerator and denominator. So remember how to factor a polynomial with multiple terms. First, you look for the greatest common factor, which in this 8n minus 96 would be 8. And when I pull out 8, we have the quantity n minus 12. Right, because 8 times n is 8n, 8 times 12 is 96. Denominator, 3n minus 36. They have a common factor of 3. Pull the 3 out, and what's left over would be n minus 12. And so again, before canceling, off to the side, I'll put the values that n cannot be. Right, I'm noticing that in the denominator here, n can't be 12. Right, because if n were 12, you'd be dividing by 0. Alright, and now that I've factored the numerator and denominator, I cancel any common. Now you could factor 8 to 2 times 2 times 2, but there are no 2's down here, so that's why I'm not doing that. N minus 12 is common to both the numerator and denominator. Now that they're both written as a product, and you see I end up with 8 in the numerator, 3 in the denominator. Alright. So yeah, like I said, this was a bad example to show you that that's a bad way of canceling. Because like even if you canceled poorly, you'd stumble across the correct final answer. But again, that's very, very lucky. That will not always happen. All right, and you saw when n was 0, we got 8/3. When n was 10, we got 8/3. The only time it won't work is when n is 12, right? When n is 12, you'd have divided by 0, and you can't do that. All right, so let me show you, again, sticking to this mistake. All right, this is bad. This is bad canceling. Look at number 6. All right. See 12p minus 240. And then 5p minus 110. Again, something I'll see people too often do. Like, oh, there's p here, there's p there, right? And then something else, so oh, 240 and 100, those have a common factor of 10, so they'll cancel the 10s too, you know? Again, this is bad canceling. You can't cancel parts of terms. You have to write numerators and denominators as products first. So people do this, they get rid of the p's, they cancel 10s, and they're like, oh, 12 minus 24, that's negative 12. 5 minus 10, that's negative 5. Oh my gosh. Ah, boy, this is not a good day. Well, that ends up being correct. Gosh darn it. But if I kept this as 240 and this is 100, say you just canceled the p's, you know, 12 minus 240 would be negative 228 divided by, and then 5 minus 100 would be negative 95. This is not 12/5, right? This would be wrong. All right. At least I don't think. All right, this is 5 times 19. Yeah, this isn't. That is 19 times 12. Alright. I'll show you in number 7 and number 8 as well. This, I know it sounds like I'm making mistakes here, or it sounds like I'm not making mistakes, but let me tell you, I mean, okay, sometimes you get lucky. This is also incredibly lucky. But you can't just cancel terms. Right. We'll eventually get to an example. I know example 7 for sure will work out that badly. All right. Anyway, so doing it the proper way, writing the numerator and denominator as a product first, factoring out, you know, the greatest common factor of 12p and 240 would be 12, and then I'd have p minus 20. There, that's the numerator written as a product. And if you want to, you know, you could factor 12 to 2 times 2 times 3. And then denominator, 5p minus 100. Greatest common factor is a 5. I pull that out, and then you have 5 times p minus 20. And now, right, now the numerator and denominator are written as products. Right, these are products, which is what you should be doing first. Right, don't just cancel stuff when there's addition and subtraction, right? You have to rewrite things as products. You won't always get lucky like I did in those mistake sections I was writing. All right, and then before canceling off to the side, I'll write down the values that the variables can't be, and I see that p cannot be 20. All right, because if I replace p with 20, the denominator will be 0, and that's not good. Right, that's undefined. All right, then now that we have them written as products, you know, there's a factor of p minus 20 in the numerator, a factor of p minus 20 in the denominator, and this ends up being 12/5. Okay, this ends up being 12/5. So no matter what I replace p with, as long as it's not 20, this fraction will be equal to 12/5. Right. So again, for some, you know, in these two examples, bad canceling worked, But please know, please know that it doesn't always work. All right, bad canceling doesn't always work, and I guarantee you that it won't work for this next one. All right, I actually looked at it this time. So again, let me show you bad canceling. We have x squared plus 4x, minus 5 divided by x squared minus 2x plus 1. So you see how these are not products, right? These are not multiplication. This is addition and subtraction, And very often, very often, I see people do this. Oh, there's an x squared here, there's an x squared here in the denominator, I'll cancel those. And then they're saying, okay, this is now equal to 4x minus 5 divided by negative 2x plus 1, and they'll leave it like that. Or they'll cancel the x's as well. Cancel the x, and say this is 4 minus 5, negative 1 divided by negative 2 plus 1 is negative 1. They'll say this is equal to 1 even. Obviously, this fraction is not always equal to 1 because the numerator and denominator aren't the same. So here's a case where bad canceling doesn't work. All right. So yes, example 5, example 6, bad canceling worked, but it doesn't always. You won't always get so lucky. So please don't do it. And you can check. What if x were 2? If x were 2, this first fraction, you'd have 4 plus 8 is 12 minus 5 is 7, and then 4 minus 4 is 0 plus 1 is 1. You'd have 7. The value of the first fraction is 7, but the value of this fraction here, if x were 2, would be 8 minus 5 is 3, and then negative 4 plus 1 is negative 3. You'd have negative 1, and 7 is not the same as negative 1, so these are not equal. Okay, so just again, just to show you, bad canceling means canceling terms before you factor. Right? You should be factoring, especially if there are multiple terms like this in the numerator and denominator. You should be factoring first, writing the numerator and denominator as a product first, and then canceling common factors. Right? You can't cancel common terms like this. So here's one where bad canceling was actually bad, right? It actually, you didn't get lucky and get the correct answer like in number 5 and 6. Right, so please, again, please factor your numerator polynomial and denominator polynomial first, and then cancel common factors. All right. So again, I'm assuming you know how to factor, so I'm going to do these kind of quickly. X squared plus 4x minus 5, that would factor to x plus 5 multiplied by x minus 1. Alright, so there's the numerator written as a product, a multiplication. Denominator, x squared minus 2x plus 1, that's x minus 1 squared. Alright, it's x minus 1 times x minus 1. And like I said, I'm going to stop listing every single little factor. Now I've written, factored the numerator and denominator completely. Off to the side, again, I'll write what the variables can't be, right? X can't be 1. If I were to replace x with 1, the denominator would be 0. So I just mentioned that off to the side. And then x plus 5 is a factor of the numerator. X plus 5 is not a factor of the denominator, so no canceling there. X minus 1 is a factor of the numerator. X minus 1 is a factor of the denominator, though, twice. So only one of those cancels, so I'll do this with powers. I'll just decrease the power by 1, by however many I would be canceling. And there we go. So the value of this fraction that I started with is the same as the value of x plus 5, right? The only factor left over in the numerator is x plus 5, and all that's left in the denominator is x minus 1 to the first, which would just be x minus 1. And there we go. And again, test it. All right, we can test it out. Now, if x were, say, 2, right? If x were 2, we saw earlier, the original fraction would be 7. Then this would be 2 plus 5 is 7. 2 minus 1 is 1. We'd get 7 equals 7. Both of these fractions have the same value when x is 2. But try it with anything, right? When x equals 0. The first fraction, the original, has a value of negative 5, right? Negative 5 over 1. So does the second fraction. Positive 5 divided by negative 1 is negative 5. You get negative 5 for the first, negative 5 for the last. They're the same value. And you can do that all day long. Replace x with anything except 1. Right? Because if you replace x with 1, you'll be dividing by 0, and that's undefined. But replace x with anything except 1, and the value of the original fraction will be the same as the value of our simplified fraction, if you did everything correctly. And you can check that out if you want. Alright, example 8. Same deal. Again, you don't do the bad canceling. Right? Don't cancel the y squareds. Don't cancel the y's. Right? This is a sum. This is a sum. These aren't products. These aren't factored yet. So I factor first. The numerator would factor the y plus 4 times y minus 1. The denominator would factor the y plus 3. Not y plus 3. Y minus 5. Sorry. Y minus 5 times y minus 1. Okay. And then again, before canceling, I've done this with all the examples, before canceling, off to the side I'll state what the value of the variables can't be. So I notice that y cannot be positive 5, right? Because 5 minus 5 would be 0. You get a factor of 0 in the denominator. Also, y can't be 1. Right? So you could replace y with any number you wanted except 5 or 1. Right? And now that I have the values I can't use, then we'll cancel. And I'm seeing the common factor of y minus 1 in the numerator and denominator. So all I'm left with in the numerator is y plus 4 divided by, and what I'm left with in the denominator is y minus 5. And there you go. All right, so this fraction I started with simplifies to y plus 4 divided by y minus 5. All right, once again, replace y with anything except 5 or 1, and the value of the original fraction will be exactly the same as the value of this simplified fraction. So I'm going to do one out loud. How about if y were 6? All right, that'd be an easy one. The simplified fraction would be 10, right? 10 divided by 1. If y were 6, the original, you'd have 36, plus 18 minus 4, that'd be 50. And then 36 minus 36 plus 5, that'd be 5. 50 divided by 5 is 10. The original fraction has a value of 10. The new fraction has a value of 10. They are the same. And they should have the same value no matter what you replace y with, as long as it's not 5 or 1. Right? And again, I leave it to you to test out some other values if you wish. Okay, moving right along. Again, just don't do the bad canceling. Alright, if the numerator and denominator have multiple terms, like they do here, this has 2 terms, this has 3 terms in example 9, don't cancel common terms. Don't cancel the a squareds. Right? Don't say, hey, 4, 16, 4 goes into 16 4 times and cancel. Right? Make this into 1, this into 4. Don't do that. Right? You have to factor first. You have to write the numerator and denominator as a product first, and then you can cancel common factors. Alright, so again, I'm assuming you know how to factor. I'm not going to go into all those methods. A squared minus 4 would factor to a minus 2 times a plus 2. So there's the numerator written as a product, right? The numerator factored. And then a squared plus 6a minus 16 would factor to a plus 8 times a minus 2. Right, and then before I cancel any common factors, I'm going to list what the values of a cannot be. Right? I can't replace a with negative 8 or with positive 2. Alright, so I could replace a with any other value, right? As long as it's not -8 or +2, because those values there will make me divide by 0, and that's undefined. Alright, so now I cancel common factors. They both have this common factor of a minus 2. And what I'm left with in the numerator is just a plus 2 divided by, and what I'm left with in the denominator is a plus 8. There we go. Again, so the value of the original fraction is going to be the same as the value of the new fraction, the simplified fraction, for any value of a, right, except -8 or 2. Right? So go ahead and try it. Replace a with any number you wish, and as long as it's not -8 or 2, and the value of the original fraction will be the same as the value of this fraction, so that what we got here, a plus 2 divided by a plus 8. Alright, example 10. Same thing, right? Numerator and denominator have multiple terms. Don't do bad canceling, right? Don't cancel the y squareds. Don't say 3 goes into 9 3 times and do some canceling. Don't do that. You have to factor first. So the numerator would factor to y minus 3 times y plus 1. The denominator is a difference of squares. That would factor to y minus 3 times y plus 3. And just as I've been doing in every example, before I cancel common factors, I state off to the side the values that the variables can't be, right? The values that will make me divide by 0, which is undefined, can't happen. And I notice that y can't be 3 or -3. So I'll write that off to the side, right? So I could replace y with any value I wish, right, except 3 or -3. And now comes the cancellation part, right? I noticed that the numerator has a factor of y minus 3. The denominator also has a factor of y minus 3, and that's it. So I'm left with y plus 1 in the numerator, and divided by, and then y plus 3 in the denominator, and I'm done, right, with this one. And again, if you want to test it out, replace y with any number you wish, except 3 or -3, and the value of the original fraction should be exactly the same as the value of this simplified fraction. Right? If they truly are equal, they'll be equal for any value of y that's allowed, right? Just not 3 or -3. Okay. Number 11, same now we're getting into a polynomial with 4 terms. So I'm going to factor that by grouping. Again, I'm going to assume you know how to factor. I'm just going to write out what the final result would be. All right, if you need to brush up on factoring, go back to the Chapter 6 material from that OpenStax.org Intermediate Algebra 2nd Edition text. Again, don't do bad canceling, right? Oh, there's p squared here and p squared there, so I can cancel them. There's a p there and a p there, I can cancel them. No, you can't. All right, you can't cancel parts of sums. Yes, in example 5 and 6 it worked, but it doesn't always. You saw in example 7 it doesn't work. The example 8, example 9, 10 here, bad canceling will get you bad results. So you must factor first. Alright, so the numerator, if I factored by grouping, we'd have p plus 3 multiplied by p squared plus 4. And that's as factored as the numerator would get. And again, to go ahead and check it out, multiply these, you'll get that back. Denominator would factor to p plus 3 times p minus 2. And then once again, off to the side, I'll write down the values that the variables can't be, right? The values that make my denominator 0, and those would be -3 and +2. So I can replace p with any number I wish, right? As long as it's not -3 or positive 2. Now that I have the numerator and denominator completely factored, I cancel any common factors, right? And the only common factor is p plus 3. Now remember, p squared plus 4, that's not factorable. That's a sum of squares, not a difference of squares. So that stays the way it is. And so I'm left with the just p squared plus 4 in the numerator divided by, and then I only have the one factor of p minus 2 in the denominator. And once again, to test it out, plug in different values of p and see if these two fractions are actually equal values. Right? Replace p with any number you want, as long as it's not negative 3 or 2, and the value of the original fraction should be the exact same as the value of this simplified fraction. Alright, then example 12, same deal. Again, I'm going to factor by grouping in my head, right, and then write the final result. Or I'll at least say what I'm thinking. Right, from the first half here, you pull out x squared, leaving you with x minus 2. From the second half, since there's a negative lead, I pull out negative 25, leaving you with x minus 2. So the numerator has x minus 2 as a common factor. That'll come out. And what would be left over would be x squared minus 25, which factors to x minus 5 times x plus 5. Right, that's a difference of squares. So there's the numerator, completely factored. And the denominator is a difference of squares, x squared minus 25. That factors to x minus 5 times x plus 5. And once again, right, as with all the other examples, before I do any canceling of common factors, I list the values that I cannot replace the variables with. So I'm noticing that x can't be 5 or negative 5. Right, because if x were 5 or negative 5, I'd have a denominator of 0. And that's not good. Right? That'll make the expression undefined. All right, now that I've listed the values that the variables cannot take, we cancel common factors. I notice the numerator and denominator have a factor of x minus 5, and they also have this factor of x plus 5. So all I'm left with is x minus 2 in the numerator and 1. Remember, technically these all become 1. 1 times 1. I have 1 in the denominator, and there's no need to write that. Right? Anything divided by 1 is itself. So all I'm left with is x minus 2. And again, to check, as I've been saying every example, if you want to test this out, replace x with any value you want except 5 or negative 5, and the value of this big fraction we were given should have the exact same value as this expression here, x minus 2. So if I were to replace x with 3, this crazy big fraction here, right, if I replaced x with 3, okay, you'd have 27 minus 2 times 9 is 18. 27 minus 18 is 9. Then negative 75 plus 50 is negative 25. 9 minus 25 is negative 16. And then 9 minus 25 is negative 16. That's positive 1. And look, 3 minus 2 is positive 1. They have the exact same value when x is 3. And it'll work that way when x is any number you want, as long as x is not, 5 or negative 5. Wonderful. All right, keeping on moving here. That's half the examples. But again, every example is the same. You factor completely the polynomial in the numerator and denominator, and then you cancel any common factors. Well, again, before canceling though, I would get in the habit of stating the values that the variables can't be. Alright, so here, 8b squared minus 32b, those have a common factor of 4b, so I pull 4b out. And what would be left over would be b minus 8. So there's your numerator factored. And denominator, right, there's a common factor of 2. And then you'd have b squared minus 3b. I'll do these one step at a time this time here. B squared minus 3b minus 40. And, we can factor this a little further. Now I'm noticing because the numerical values here, 2 and 4, have a common factor, I'm going to break 4 up. I'll write 4 as 2 squared. So we have 2 squared times b minus 8 divided by, and then you got this factor of 2 here, and then b squared minus 3b minus 40 would factor to b minus 8 times b plus 5. And then just as I had before, right, with all the previous examples, before I cancel any common factors, I'm going to list the values of the variables that I can't use. Right? B cannot be 8 or negative 5. Right? So I can replace b with any number I wish except these two, because they'll make me divide by 0. And then I cancel common factors. b minus 8, b minus 8. And there's 2 down here, and there are 2 2's up here, so I'm going to decrease the power by 1. Right? I'm canceling one of the 2's, so I have 2 to the first. Okay, so I'm left with 2 to the first, times b to the first in the numerator. And that's it. Right? The other factor is 1 canceled. And then all I'm left with in the denominator is this factor of b plus 5. And there we go. Right, so the value of this fraction I was given is equal to 2b divided by b plus 5. And this is for every value that's allowed. Right? These should be equal when you replace b with any number you want, except 8 or negative 5. Okay. Now, example 14. Same stuff. The only thing I want to point out from example 14 that'll also come into play in later examples is that in these numerator and denominator polynomials, see the lead term, the highest powered term, has a negative coefficient. So we have a negative lead coefficient in these polynomials here. And you might recall from chapter 6 material, or whatever videos on factoring I've put out, or whatever reading on factoring you've done, we'll factor out a negative in that case. The opposite of whatever the greatest common factor is, the opposite of the GCF. So what I would do then, and I'll do a couple steps for this one as well. So you have negative 5c squared minus 10c, right? The greatest common factor would be 5c. Right? 5c goes into both terms. But because the lead coefficient is negative, I'll pull out negative 5 times c, or the opposite of the greatest common factor. And if I pull out negative 5c, what would be left over is c plus 2. Right, and you can redistribute and check and see that that's the same as the numerator there. And then same thing with the denominator. The greatest common factor of all three of these terms is 10, but because the lead coefficient is negative, I'm going to pull out negative 10. And then what I'd be left with now is c squared minus 3c minus 10. And you can redistribute and see that that's the same polynomial as the denominator. And then we factor a bit further. Now, one thing I'll point out here also is that we have a negative factor. I'll cancel those right now. That'll make it. This is going to be positive. Have a positive lead coefficient here. The negatives cancel. So I've got 5 times c plus 2 in the numerator, right? When that's totally factored. And then 10, I noticed that 5 and 10 will have a common factor. So I'm going to break 10 up into 2 times 5 just to get that common factor exposed. and then the other factor, c squared minus 3c minus 10, that factors to c minus 5 times c plus 2. All right, and then as with all the previous examples, before I cancel any common factors, or I know I already canceled the minuses, but that was just to make it look cleaner. Before I cancel any factors with variables, I'm going to state the values that those variables can't be. And based on this, looking at the denominator, c can't be 5 or negative 2. Because again, if c were 5 or if c were negative 2, I'd be dividing by 0 here, and that's not good. All right, so now I go through and cancel the common factors. You have 5 up top, 5 in the bottom, c plus 2 up top, c plus 2 in the bottom, and that's it. So this is equal to c in the numerator divided by, and then you could leave things factored if you want. There's nothing wrong with that. 2 times the quantity c minus 5. All right, this is totally valid. Or you could actually multiply it out. C divided by 2c minus 10 when you actually distribute. Okay, but you can leave things factored when you're done, or multiply it out when you're done, same thing. And again, to check, if you want to test it out, replace c with any value you want except 5 or negative 2. And the value of the original expression, the original fraction, should be the exact same as the value of the simplified fraction. So again, check that out on your own. All right. So now we're getting into some examples here with 2 variables. I know we saw some of those earlier, but this is going to be, you'll see when I list off the values that the variables can't be, it's going to be a little trickier. The factoring still works kind of the same, right? So for example 15, numerator, I have a common factor of 3. Pull that out. And then we have, m squared plus 10 mn plus 25n squared, and this is one of those perfect square trinomials we'll see in a second. Divided by, and then here there's a common factor of 4, and I'm left with m squared minus 25n squared, and that's a difference of squares. All right, factor in the numerator completely. We have 3 times the quantity m plus 5n squared. All right, that factor there is m plus 5n times m plus 5n. And then we have in the denominator we have 4 times, and then m minus 5n times m plus 5n. All right, it's a difference of squares. Now, before I cancel, right? Before I cancel any factors with variables, I'm going to list the values that the variables can't be. Now, there's an infinite number of values this time. See how m can't be equal to 5 times n, right? m minus 5n can't be 0, because that'll make the whole denominator 0. So that means m can't be 5 times whatever I choose for n. Same thing with m plus 5n. This can't be 0 either. So n can't be equal to 5n or negative 5n. So I'll show you an example, and that means if I replace n with 1, I can't replace m with 5, because that's 5 times 1. If I replace n with 2, I can't replace m with negative 10, because that's negative 5 times 2. This just gives me a relationship here telling me the relationship I can't use between m and n. Now I could replace m with 1 and m with 6. That'd be fine, right? But again, just so long as m is not 5 times your choice of n, and m is not negative 5 times your choice of n as well. All right, as long as those aren't happening, you're not dividing by 0 and it's okay. All right, so now we simplify, cancel common factors. There's m plus 5n, and there are two m plus 5n's in the numerator, so I'm just going to cancel one of those, right, decreasing the power there by 1. So in the numerator I have 3 times, the factor of 3 times the quantity m plus 5n divided by, and then denominator I have a factor of 4 times another factor of m minus 5n. And again, this is totally fine. You can leave everything factored when you're done, just so long as all the common factors are canceled. Once again, though, you could also just multiply it out. Right, there's nothing wrong with this either. Right, or you could distribute the 3 up top, say 3m plus 15n over, and then distribute the 4 on the bottom, 4m minus 20n. That would also be the same. Right. But again, just so long as m is not 5n, you can replace m and n. You can replace m and n with any values you want. And the value of the original expression should be the same as the value of this last expression. The only values of m and n you can't use are ones such that m is 5n or negative 5n. Right, so that means again, you can't use 10 for m and 2 for n. Right, that would make me divide by 0. I can't use 100 for m and negative 20 for n, because that would make me divide by 0. Right, but any other combinations of m and n are fine. You could have m be 7 and n be 2. You could have m be 20 and n be 13, whatever. And the value of the original fraction should be the same as the value of this last fraction I had after simplifying. All right. Okay, very similar. Example 16. The numerator here, greatest common factor is 5, so I'll pull a 5 out. And we have r squared plus 30rs, 6rs. I pulled a 5 out. 6rs minus 7s squared. Alright. And there is no common factor in the denominator, that's just a difference of squares, so I'll just factor that right now. That'd be r minus 7s times r plus 7s. And then I totally factor the numerator. We'd have 5 times this r squared plus 6rs minus 7s squared would be r plus 7s times just r minus s. And then we had r minus 7s and r plus 7s in the denominator. Alright, and then again, before I cancel anything, I'll notice that r cannot be 7 times s or negative 7 times s, because if r is 7s or r is negative 7s, the denominator will be 0. So once again, like in example 15, that means if I choose s to be 1, I can't choose r to be 7. Right? If I choose s to be 5, I can't choose r to be 35 or negative 35, because that'll make me divide by 0. So, but you can replace r and s with any other combination, right? I could replace s with 5 and r with 40. That would be fine. I could replace s with 2 and r with 17. That would be fine. All right, then I do the cancellations of common factors. There's just r plus 7, r plus 7s. So what I'm left with in the numerator are the factors of 5 times the quantity r minus s. And in the denominator I have just simply r minus 7s. So this is totally fine here, totally simplified. Or distributing the 5, there'd be 5r minus 5s divided by r minus 7s, same thing. Either one would be fine. And then once again, you could test it out. Plug in values for r and s and see what the original fraction's value is and see what this simplified fraction's value is. And they should be the same, right? They should be the same. As long as r is not 7 times or negative 7 times your choice of s, you're fine. Okay. Moving on now to example 17. Now examples 17 and 18 are very, very similar. Just, one has the variable d and the other has the variable a. Now the thing I want to point out in example 17 is, look at the numerator. You have a minus 5. The denominator, you have 5 minus a. Notice it's the same two numbers, a and 5, just opposites. 5, negative 5, a, negative a. So these are opposites. Right? These expressions are opposites. One of these is negative 1 times the other. One thing I like doing is I like writing all the polynomials I have in descending order. So where the highest power of the variable is first and then goes down. So the numerator is already in descending order. The denominator I could rewrite as negative a plus 5, right, if I wrote it in descending order. And then I'd notice, oh, look, in this polynomial in the denominator, after I've written it in descending order, this has a negative lead coefficient. Like an earlier example, I forget what example number that was. And remember, if you have a negative lead coefficient, you should be factoring out the opposite of the greatest common factor. So the numerator is a minus 5. The denominator, negative a plus 5, the greatest common factor there is just 1. But because the lead coefficient is negative, I'm going to pull out or factor out negative 1, right? The opposite of the GCF. So if I do that, we have negative 1 pulled out, or just a minus sign. And then if I pull that out, there'll be a minus 5 left over. And very clearly now you can see that the numerator and denominator are opposites. All right, the numerator is a minus 5, the denominator is negative 1 times a minus 5. And when you cancel the a minus 5s, you're left with 1 divided by negative 1, or just negative 1. Right? And that's, oh yeah, I forgot to write out a can't be 5, right? I forgot to do that. Before canceling, like in every other example, before I did the canceling, I would notice, hey, a can't be 5 though, right? Because that'll make me divide by 0. So I'll put that off to the side. So the value of this expression, this first fraction, will be equal to negative 1 no matter what you do, no matter what you plug in for a. And go ahead and test that. As long as a is not 5, right? Because you'll be dividing by 0. When a is 6, you'd have 1 divided by negative 1, which is negative 1. When a is 10, you'd have 5 divided by negative 5, which is negative 1. Right? No matter what you plug in for a, as long as it's not 5, this fraction will be equal to negative 1. And the same thing goes for this next one. If I write the polynomial, example 18, if I write the polynomial in the numerator in descending order, right, that'd be negative d plus 5 divided by, and then, that's already in descending order, d minus 5. I factor out the negative 1 from the numerator. You'd have the opposite of d minus 5, right, divided by d minus 5, and like, oh look, the numerator and denominator have this common factor of d minus 5. And before I do any canceling, I'll say, hey, d can't be 5, right, because that'll make it divide by 0. Cancel the d minus 5s, and I'm left with negative 1 divided by 1, which is again negative 1. And that's going to happen anytime you have opposites, right? Anytime the numerator and denominator are opposites, they'll divide to be negative 1. So the value of this first fraction is the same as negative 1 all the time, as long as d is not 5. Right? Replace d with anything else, and that will be a true statement. Alright, so same kind of deal with 19, where I have a polynomial that's not written in descending order. I prefer them in descending order, so I'm going to rewrite that numerator as negative 5y plus 20. And the denominator is y squared minus 16. I'm going to factor that right now. That's already in descending order. That's a difference of squares. That's y minus 4 is a factor. Y plus 4 is a factor. And then from the numerator, I pull out the opposite of the GCF because the lead coefficient is negative, which would be -5. So I factor out a -5 from the numerator, and if I do this, I'll have y minus 4 left as another factor, divided by y minus 4 times y plus 4. And then before I do any canceling, I'll note to myself that the value of y cannot be 4 or -4, because those will make me divide by 0. But y can be any other number, and I'll be fine. And then they've got y minus 4 as common factors. Alright, and then the numerator I'm left with -5. In the denominator I'm left with y plus 4. And that's as simple as that would get. And once again, I'll say it over. I've said this every example. You want to test these. You want to see, hey, are these fractions I was given? Is this fraction I was given actually equal to what I wrote at the end? Replace y with any number you want, as long as it's not 4 or -4, and the value of the original fraction should be the same as the value of what you got at the end. Alright, number 20. Very similar. We have 4v minus 32, that's already in descending order. And 64 minus v squared, that's -v squared plus 64. Alright, now you could also say, hey, that's a difference of squares and do it faster, but I'm going to do this way. Numerator, got a common factor of 4, pull that out. That would be 4 times v minus 8. Denominator, I'm going to pull out the -1 because the lead coefficient is negative, and then we have v squared minus 64 left over, and that's a difference of squares, which I can factor further. So we have 4 times v minus 8 in the numerator, and then I can put the negative sign out front, because I got a positive coefficient in the numerator and negative in the denominator. That's going to give me a negative response. So I'm just kind of moving this negative out in front here, out in front of the fraction symbol. And then I have v squared minus 64, that would factor to v minus 8 times v plus 8 in the denominator. And then as with all the other examples, before I cancel any common factors with variables, I'm going to note what those variables cannot be. And I'm seeing that v can't be 8 or -8, because that would make me divide by 0. Canceling the common factors of v minus 8 here. What I'm left with is, negative, or the opposite of 4 in the numerator. That's all that's left, divided by, and then v plus 8 in the denominator, and there we go. And once again, if you want to test this out, replace v with any number except 8 or -8. And the value of the original fraction should be exactly the same as the value of this final expression if you did everything correctly. Alright, I've got one final page, and it's all the same. Right. Factor the numerator, factor the denominator completely, cancel any common factors, also listing values that the variables can't be. Alright, so here the numerator is a sum of cubes. And again, I'm assuming you know how to factor in different methods. This is w cubed plus 6 cubed. So that'll factor to w plus 6 times w squared minus 6 times w plus 6 squared plus 36. All right, sum of cubes. And that doesn't factor any further. And then w squared minus 36 is a difference of squares, which will factor to w minus 6 times w plus 6. And then before I do any canceling, I'm going to note that w cannot be 6 or -6, right? Because that'll make my denominator 0. All right, so for any other value, besides 6 or -6, the value of this expression will be equal to the following, right? You can't cancel the common factors of w plus 6. And what I'm left with in the numerator is this w squared minus 6w plus 36 divided by, and then w minus 6. And that's it. That's as simple as that's going to get. No more common factors. And again, if you want to test this, replace w with any value you want, as long as it's not 6 or negative 6, and the value of the original fraction, the original expression, should be exactly the same as the value of the final fraction. Alright, example 22, very similar. We have a sum of cubes again in the numerator. That's v cubed plus 5 cubed. Right. So that'll factor to v plus 5 times v squared minus 5 times v plus 5 squared. That's plus 25. And the denominator is a difference of squares, v minus 5, v plus 5. And I'll note that v cannot be equal to 5 or negative 5, right, because that'll make me divide by 0. So this will be good for any other value, any value of v besides 5 or negative 5, and then cancel the common factors of v plus 5 in the numerator and denominator. Numerator is v squared minus 5v plus 25 divided by denominator is v minus 5. And once again, test it out. Replace v with any number you want except 5 or negative 5, and the value of the original fraction should be exactly the same as the value of the simplified fraction when you replace v with the same number. Alright, and finally, examples 23 and 24 look pretty similar. Numerator, that'll factor to z minus 5 times z minus 4. And in the denominator, as in examples like 20, 19, 18, and 17, if you look back at those, I would rewrite this, as a negative z squared plus 16, and then factor out a negative 1, and that'll pull that negative out front. You'd have z squared minus 16 left, which will factor to z minus 4 times z plus 4. And so I'll make a note that z, right, the value of z cannot be 4 or negative 4, because that'll make me divide by 0. Cancel the common factors of z minus 4 here. And what I'm left with is the opposite of, or negative, and then the numerator is z minus 5 divided by, and then the denominator is z plus 4. So you can leave it this way, or if you want to put the negative in the numerator, that could be 5 minus z divided by z plus 4, same thing. Alright, and once again, test it out, try different values of z, as long as it's not 4 or negative 4. Right? Replace z with anything you want except these two, and the value of the original fraction should be the same as the value of what I got at the end. And I'll leave it to you to do some practice testing some of that out. Alright, and the last one, 24, a squared minus 5a minus 36. That would factor to a minus 9 times a plus 4. And same as with the 16 minus z squared, 81 minus a squared, I would think about as negative a squared plus 81 and pull out a negative. So then I'll pull that in front of the fraction. Then you'd have a squared minus 81, which will factor to a minus 9 times a plus 9. And then before doing any canceling, I'll make a note that the value of a can't be 9 or negative 9, right? But it can be anything else. Cancel the common factors here of a minus 9, and here we go. Right, this would be negative in the fraction a plus 4 divided by a plus 9, and there we have it. Right. Again, test it out. Replace a with any number you want, except for a 9 or negative 9, and the value of the original fraction should be exactly the same as the value of what I got in the end after simplifying. Alright, so a lot of examples again where I'm doing the same thing every time. Alright, to simplify a fraction, you factor the numerator and factor the denominator completely. Make a note of what values the variables can't take. That'll make me divide by 0. And then cancel any common factors that the numerator and denominator might have. Alright, so hopefully watching me go over a bunch of these helps you out when you're practicing problems like this on your own. And thank you very much for watching.